Welcome to an explanation of the differences between RT bolt load measurement and current bolt load measurement methods. Currently, both ultrasonic elongation measurement and mechanical elongation measurement methods are used to monitor bolt load during assembly and on occasion during operation. But these methods have limitations that prevent widespread use for joint quality control and quality assurance. This means at present that they are typically only used on only the most critical of joints. So what is holding back these current methods? They are not bad, they just have some limitations that prevent their wider use, which we will summarize as CARL, or C-A-R-L. Cost. Cost on a per-bolt basis is relatively high, particularly when you factor in the time and manpower required to use them. Accuracy. The devices typically have insufficient accuracy without an initial unloaded bolt length measurement. This means you need to track each bolt individually, and this takes time and has the potential to introduce errors. Reliability. Poor repeatability with temperature and complex construction of the devices leads to a higher likelihood of poor reading, which defeats the purpose of using them in the first place. Logistics. There is a practical limitation on the number of joints that can be inspected due to the time required for measurement, but also due to supply limitations, with supply delays expected on large projects and 1 to 2 month pre-order delays for equipment, even for measuring single critical joints. Looking at the problems in a little more depth for ultrasonics. There is an initial investment required for the ultrasonic equipment and then ongoing bolt machining and identification costs. Ultrasonics requires a highly skilled operator to get accurate measurements, so its use is always limited by skilled operator availability. It can be accurate, but only if used properly. It can be very inaccurate if used improperly, resulting in worse load control than torque. It requires machining of the bolt ends to ensure accurate measurements and measurement of unloaded bolt length, which is an additional pre-assembly operation. It requires identification of each bolt and is not effective on stainless steel bolts. In addition, the accuracy of ultrasonics is questionable when the joint is at temperature or sees high levels of bolt bending. Due to these factors, ultrasonics is not considered suitable for operational measurements or residual load measurements after operation at high temperature. The other common alternative is conventional mechanical elongation bolt load measurement. These devices are manufactured in bespoke factories using highly specialized processes. This means that there are limitations on device availability due to production capacity. There are a limited number of the devices available, and often there is schedule impact due to project timing, particularly if a large number are required. Since the suppliers are not an integral part of the site or project supply chain, or in other words, are not the standard bolt supplier, they do not represent a typical bolt that will be used on site, which makes them less useful for overall quality control. There are, in all cases, multiple components installed internally into the bolt. In many cases, these components are only force-fit or glued in place. This reduces the reliability of the device, particularly with temperature, vibration, and bending. In some cases, the alignment between bolt surfaces and the measurement tool are insufficiently accurate to enable readings to be taken without an initial no-load measurement being taken first. In other cases, the device will only measure that the load has been exceeded, or in other words, the device does not indicate the actual bolt load. And finally, cost. Because there are multiple components and an intricate manufacturing process for each bolt, this leads to high delivery cost for the devices compared to normal bolt costs. So now let's look at the advantages of RT bolt. RT bolt is made with 4 conventional machining steps and 2 electrical discharge machining steps. The central pin is formed from the bolt using EDM, so there are no joins, no force fits, no glue, no adhesives, and no different materials. This results in no moving parts in the bolt, with pin and gauge alignment being integral, which gives readings that are unaffected by temperature, vibration, and bolt bending. The fully automated precision machining process occurs in a matter of minutes per bolt, so there is lower cost associated, with no double handling, shorter delivery times, and no limitations on capacity of manufacturing process in any region. Machining can be performed at the site's preferred bolt manufacturing location by the manufacturer, resulting in preservation of the supply chain integrity for the bolts. In terms of accuracy, the RT bolt improves on current methods, as the gauge-to-bolt alignment is achieved via close fit to the bore of bolt, which results in much higher accuracy than conventional methods. The internal datum surfaces are precision prepared using an electrical discharge machining process, which incorporates an automated quality control step, ensuring all bolts meet the accuracy specification required. The resulting accuracy improvement means that an initial unloaded bolt reading is not required, which results in a significant improvement in measurement time and eliminates the need for bolt identification. In terms of cost, RT bolt improves on the current methods, as the elimination of the need for an unloaded bolt reading means much faster measurement of bolt loads is possible. Faster measurement allows more measurements to be taken, which drives a lower overall cost. Minimal operator skills are required, meaning that there are no limitations on the extent of use due to operator availability. RT bolt can be used both during assembly and post-assembly to verify that the target bolt load has been achieved. The lower cost and operator skill level enables RT bolt to be used for in-process inspection of bolted joint assembly, in the same way that RT inspection, radiographic testing, is used for welded joints. RT bolt is radiography for bolted joint assembly. RT bolt can be used as a probe to randomly inspect joints both during and after assembly. RT bolt can be permanently installed or periodically installed to monitor bolt load during assembly and operation. RT bolt works with assemblers at their pace or as an integral part of their process for the best value for money quality assurance effort possible for bolted joint assembly. RT bolt, radiography for bolted joint assembly.